I hope none of my customers ever need this video, but it's inevitable that an eventuality that a bolt pattern gets poured in correctly. Here's what first we need to ask some questions. Are the bolts less than the diameter of the bolt out of tolerance? 1/8 of an inch, gravy. 1/4 of an inch, a little bit of a pain in the ass. Several inches or outside of the base plate completely, here we're probably okay, but we can't use them, which means we'll be drilling. Are they out of place so that the misplaced bolt is within its diameter to the edge of the base plate and less than 1/2 inch or so from where the bolt should be? That's disaster. Very limited options here, and they all suck. If your bolt or bolts are 1/8 of an inch to 1/2 inch out of place, we can ream or burn the base plate of the column to make a slot. This is fine, and it's allowed in the structural code, but you should confer with us first just to make sure that everything is covered. When you slot, you'll need to use a larger washer, obviously, and in some rare cases, puddle welding or welding the bolt to the base plate may be necessary. Those are on high seismic buildings, very large buildings, so pretty unusual. Also, if you've had us review the issue first, and if your building authority or inspector or client, whatever, requires it, we can send an engineer sealed letter approving the field work. Okay. If your bolts are more than double their diameter out of place, a good solution is just to drill a new hole in the base plate. Of course, that only works if the new hole's edge is more than equal to the diameter of the bolt from the end of the plate. Nut tolerance can be an issue here too. So make sure that the nut has enough clearance from any of the flanges or webs as you twist it down so it can turn. As with all of these fixes, you should be reaching out to us prior to modifying any of the building parts. Okay, that covers most of the issues that we wind up with, but let's say that the bolts aren't even in the ballpark and what we've just gone over isn't going to work. This means we're drilling and setting new bolts. Once you're 100% sure that the bolts that are in place can't be used, go ahead and cut them flush with the concrete and then lay out the correct locations. You'll need a heavy-duty hammer drill, and because wedge anchors are never to be used for any load-bearing column, you're going to need some slightly oversized drill bits, assuming that we're going to be using epoxy as the anchoring method. I think for most applications, the hole diameter is 1/8 of an inch larger than the bolt diameter. So a 3/4 inch bolt will need a 7 1/8 inch hole. And also be sure to get drill bits that can go through rebar. Trust me on this one. There are several epoxy products available, but Hilti is the industry standard, so we'll go over some basic Hilti stuff. A few things here. The hole must be prepped after it's drilled, and you'll need to remove all dust and debris from the hole. Compressed air and a hole brush are typical. If the hole is not completely clean, the epoxy just won't adhere correctly to the concrete. We also need to make sure that you're using the correct epoxy for the depth of the hole you're drilling, or the other way around. There are different strength epoxies, and they all require different depths based on the load requirements. Hilti High Yield 100 or HY 100 is pretty common. I would, however, recommend that you reach out to whoever designed your foundation or to us here at Great Western for some assistance deciphering the anchor bolt reactions so that we can determine the depth and the epoxy required for that bolt. Hilti does have charts that are easy to use, and they're available online as well. Once your holes are drilled and prepped, you can then squeeze in the epoxy and then place the bolt. Be sure to read the instructions and wait the appropriate cure time, which is on the label on the back of the bottle, which is usually based on temperature. Anyway, you want to make sure that it's cured before you place any steel on the bolts. Also, these epoxies are pretty expensive, 50 to 75 bucks a tube, and a special gun is needed, I think, with the Hilti stuff. Maybe you can use a regular one, but it just will kill your arms. This is particularly important to know if you're deciding to not place any bolts during the pour, just to come back and drill an epoxy later. In my opinion, it's not worth it. It's going to cost more money, and it's going to take a lot more time and work. And there are some other less expensive products available at the big home centers, like Silka, but I do recommend Hilti. There's also screw-in concrete anchors that are suitable in some circumstances, usually like very lightly loaded columns. I don't have a lot of experience with these, so I'm just going to leave that there and let you decide which way to go. And that pretty much covers it. But in very unusual circumstances, serious modifications to the columns may make sense. And I've seen big issues that require concrete to be cut out, re-poured, the whole nine. And it's usually because the pier is at the wrong elevations or the pier itself is in the wrong place. But that is very unusual. Okay, I realize I've made this sound scary and possibly overwhelming. But it really isn't. This video is really just there for worst case scenarios and some simple field fixes. And I guess the point to all of this is just to take your time and check. And I've said it before, check, double check, recheck, and then check again that your bolts are correct prior to pouring your concrete. As always, we're happy to jump on the phone with you or your contractor to go over any of this, answer simple questions. We can even review photos and measurements, so long as that they're clear enough for us to understand. So please reach out if you're unsure about anything. I appreciate you hanging out with me. And like I said at the beginning of this video, I hope no one ever needs to watch it. Anyways, build great. I'll see you in the next video where we'll be putting up the mainframe columns for this building and setting some other steel. Take care.